Title: In the realm of uncertainty, in a modest laboratory nestled within the corners of an aged university, Dr. Albert Bennett found himself confronted by an enigma that had bewildered scientists for decades. He was an esteemed physicist, devoted to unraveling the mysteries of quantum mechanics, and his current pursuit was understanding Heisenberg's uncertainty principle. Dr. Bennett was a tall man in his mid-50s, with silver streaks in his hair hinting at years devoted to intellectual inquiry. His passion for physics was matched only by his love for teaching the handful of curious students who dared to venture into the quantum realm. Today, his class was lively with questions, a rarity he cherished. James, one of his brightest students, stood out with his piercing inquiries. So, Dr. Bennett, is it true that you cannot precisely measure both position and velocity at the same time? How does that not contradict everything we learned about classical physics? Dr. Bennett appreciated James's inquisitiveness. Excellent question, James. You see, in classical physics, we can measure both position and velocity simultaneously with great precision. But in quantum mechanics, particles such as electrons behave in ways that defy conventional logic. The act of measuring one quantity affects the other, a fundamental concept introduced by Werner Heisenberg. He took a photograph from his desk and showed it to his students. Imagine trying to capture an image of a hyperactive child using a camera with a slow shutter speed. You might get a blurry picture. Now, apply that analogy to particles at an atomic scale, influenced by countless invisible forces. He paused, allowing the silence to stretch just enough to let his students digest the idea. This principle, known as Heisenberg's uncertainty principle, states that the more precisely you try to measure one property, like position, the less precise your measurement of the other property, like velocity, becomes. It's not just a limitation of our technology, it's a fundamental property of nature itself. The grip of silence loosened as curiosity resurfaced among the students. Sarah, who had been quietly observing, raised her hand. Does that mean that nothing is actually certain at the quantum level? Dr. Bennett nodded thoughtfully. Precisely. At the quantum level, we find a universe abundant with probabilities rather than certainties. This doesn't deny the existence of truth. Rather, it expands our understanding of it. As the class concluded, Dr. Bennett felt a sense of fulfillment. He had not only explained the principle, but had also instilled in his students the significance of embracing uncertainty, a concept vital not only to physics, but to life itself.